Hello friends, welcome to my channel. In this video, we will see solution of the DC machine chapter of the Parker Smith book. This is the second video on the DC machine chapter. The first video link is in the description. You can watch it there. So let's see. This question is the 12th question of the DC machine part of the Parker Smith book. The question is saying the armature of a two-pole 200 volt generator has 400 conductors and runs at 300 revolutions per minute. Calculate the useful flux per pole if the number of turns in each field coil is 1200. What is the average value of electromotive force induced in each coil on breaking the field if the flux dies away completely in 0.1 second? So it has given the data for armature circuit and the field circuit. So let's understand it more. It has given for the armature pole is 2, number of conductors are 400 and N is 300 rpm. If you can convert it to rps, rotation per second or revolution per second, it will be 5. So it is asking about the flux per pole, useful flux per pole. Simultaneously, it has given that field turns are 1200. So in d5 by dt, it has given the dt value. The phi value will get it from here and dt value is given 0.1. So you have to calculate the EMF induced. So let's solve the question. So we know that induced EMF in the armature is given by, this is the DC machine formula, induced EMF formula, E equal to P phi Zn by 60A, where remember that where N is in RPM, not in RPS. N is in RPM. If N is in RPM, this denominator 60 term will come. If N is in RPS, the 60 will not come. So here P is the number of poles and phi is the flux per pole. So here it is not given whether it is lap or wave. So if the pole is 2, the parallel path will be 2. Anyway it will be 2, because for lap we take A is equal to P and for wave we take A is equal to 2. So if P is equal to 2, then A will be 2. So anyway P and A are equal, that is 2. So we can cancel this P and A here. So finally E will become H, E equal to phi Zn by 60, where pole equal to 2. So if you put the values of E, Z, N, you can calculate phi. Phi will be 0.1 Weber. This is the answer for this first part. The useful flux per pole will be 0.1 Weber. So let's see next part. So it is saying if the flux dies away completely in 0.1 second, means we can calculate d phi by dt. Here we have calculated phi equal to 0.1 Weber. So if the flux dies away, means change in flux is 0.1 to 0, means the change is 0.1 and the time is 0.1 second. So you can divide it by time. So finally it will become 1. So d phi by dt is nothing but 1. We have calculated it here. So according to Faraday's law, we know that magnitude of induced EMF is nothing but magnitude of induced EMF is nothing but N divided by dt, where N is number of turns. So here it has given number of turns equal to 1200 of the field circuit. So 1200 into 1 equal to 1200 volts. So the induced EMF magnitude will be 1200 volts. That is the answer to this part. So that's all for today. If you like it, give a thumbs up and don't forget to subscribe.